Okay, well, let's assume that we're using the same example that we used before with education majors. But in this test, let's keep everything the same. Let's keep the population mean at 2.70. Let's keep the sample population, the sample mean at 3.0. The standard deviation is the same. However, let's say that our n is less than 100, that our n is 50, right? This means that when we're going through our 5-step model, that the first step is that this, that n is, for our first step, n is not greater than 100. That means that we can't use a normal curve, that we have to use what's called a t-distribution. In a t-distribution, we have to find our degrees of freedom. Our degrees of freedom is simply n minus 1, right? So we'll follow the same steps that we did, and we'll do everything that we did the same way, right? So our z obtained is the sample mean minus the population mean divided by n minus 1, right? And we got a z obtained, I believe it was of 4.65, right? Or somewhere close to that, so just do the math, right? But there's a difference here, right? We can't use a normal curve, so that means that we have to use the t-distribution. So that means that we have to take one additional step, degrees of freedom. Our n was 117. So that, our mean was 50. So that means our degrees of freedom is 50 minus 1, which gives us degrees of freedom of 49, right? So we can't plug this into the normal curve and have our rejection regions, right? Even though we know that this still remains a two-tailed test, right? And our rejection regions are still, there. The deal that we have to do now is we have to go to the back of the book, and we have to go to table number 7. So you go to table 7. It's all the way in the back of your book in the appendix. And the first column reads degrees of freedom, right? So you look at the first column and you go down. And you go down to 49 if they have 49, right? So they don't have 49, so you take the closest number. In this case, it's 50. And you look at the top row, it has your level of error. And your level of error that you're willing to accept here is 5% error, right? Because that is the error that we're willing to accept as social scientists, right? So we go to the top to 0.05 and we come down to 50, and that gives us a level of error that we're willing to accept of 1.67. So from the table, our error that we're willing to accept is 1.676, right? And we know that our z obtained is greater than this. So again, we will reject the null and state that there is a statistically significant difference. This is just an example of a small sample, a n of less than 100.